We are working with graph properties, so we have this graph and we just need to find the information that we know about this graph. So the first question is, what kind of leading coefficient does this have, a positive or a negative? So I know that this is an x cubed. Sorry, I can go ahead and do that. That's an x cubed graph. An x cubed looks like this. And so I know that this is with y is equal to x cubed, and that's with a positive leading coefficient, and that is what I have as far as my end behavior goes. So I'm looking at the ends, and on the right hand side, as my x's are getting bigger towards infinity, my y is also getting bigger towards infinity. On the left side, my y's are going towards negative infinity as my x's go towards negative infinity. So my leading coefficient is positive, and I do have a cubic graph. My real zeros, I'm going to go ahead and mark my real zeros with an X. So I have one here, I have one here, and I have one here. So I have a total of 3 real zeros. So a real zero is wherever the graph crosses or touches the x-axis. And the zeros with I, that's going to happen if I have a graph that could have crossed the x-axis but did not. So right here, you'll notice that spot could have been higher and crossed the x-axis with that little bump right there, but it didn't. That would be an imaginary zero if I had something like this, but I don't have that, so I have none with I. Next question, we're going to do all of these with this graph. First thing I'm going to state is the degree. So again, this looks like a cubic. This would be a negative x cubed. So I know my leading coefficient has to be negative because it's reversed. This is y is equal to negative x cubed. And again, I can tell by my end behavior. This is a degree of 3 because it is a cubic. I keep drawing just y equals x cubed, but we know that it could have a more defined curvature there with 2 little bumps, a local max and a local min. The zeros, I have one here and I have one here. So one of my zeros is x is equal to negative 1. That's going to have a multiplicity of 2. Again, we touch the x-axis, we don't cross it. That is a multiplicity that is even, and this is a cubic, so I believe it's a multiplicity of 2. The other zero is that x is equal to 5, and that has a multiplicity of 1, which we don't generally state. Then we have our factors. Once we have our zeros, we should be able to find our factors. So if x equals negative 1 is a 0, that means x plus 1 has to be one of my factors. It had a multiplicity of 2, which means that factor is squared. Then if I have x is equal to 5 as one of my zeros, then x minus 5 has to be one of my factors. So here are my factors, and I don't have to write it in factored form. They ended up being in factored form. Now we're moving on to our end behavior. So as x is going towards negative infinity, so that is this direction, which means I'm looking here. My y is trying to go to negative infinity. That is not true. It looks like as x approaches negative infinity, my y is going to positive infinity. So as my x's get really small, they're going to the negative direction. My y values are getting bigger and bigger and bigger, so my y values are going towards positive infinity. Then if we look as x approaches positive infinity, which is this direction, that means that my y values are going down and trying to approach negative infinity. So this is what I have as well. For the first one, if x is going towards negative infinity and y is going towards negative infinity, we need something looking like that. And for that very last option, as x approaches positive infinity, y approaches positive infinity, we're looking for something that looks like that, which I do not have in this graph. What I do have is as x goes to infinity, y goes to negative infinity, and as x goes to negative infinity, y goes to positive infinity. So I have the red arrows happening in my graph. The x-intercepts, we're writing them as coordinates. Those are going to be, we had 1, 0 at x equals -1, so that coordinate is -1, 0. We have a 0 at x equals 5, so that coordinate will be 5, 0. The y-intercept, that is going to be up in here, and I zoomed in a little bit, and I believe that that happens when y is 2.5. We will give you prettier ones on assessments, but I believe the y-intercept is at 2.5, so writing that as coordinates would be 0, 2.5. My domain and my range, I don't have any issues, so it looks like my x's can go from negative infinity to positive infinity, and the same thing for my y values. I can go from negative infinity to positive infinity. So all real numbers would be my domain and my range. We have one more. We're going to sketch this graph. To start, I need to be looking at the degree and the leading coefficient. So to look at the degree, what I'm going to do is I'm going to take each of the x's and I'm going to multiply them together. But I need to be very careful about one of them. One of them is squared. So I have that first x, then I have another x, then I have an x that's inside of a squared, and then I have a final x. When I multiply those all together, I'm going to get x cubed times x squared. This is going to be an x to the 5th. So my degree is 5. That is an odd exponent, so odd degree, so I'm going to have something that looks like this. With a 5th, though, I would have an opportunity for more bumps involved, but it should look like this. Now I need to look at my leading coefficient. So my leading coefficient would be, what sign would this be? And this has a negative right here, actually, for this x right there, which would ultimately make that negative. So my leading coefficient is negative, which means I am now reversed. So what I thought I was doing, now I'm going to reverse it, and I'm going to have something like this. I don't have to have all of those bumps in there, but something, that shape. The key here is the end behavior, what's going on at the ends. So I'm going to go ahead and put my zeros down now. And my zeros are, this one gives me x equals 0. That looks like my y-intercept as well. So my y-intercept is at 0, 0. This one's going to give me x equals -4. So this one is going to give me x equals -2. I need to be careful with this one. I'm going to put a little x here. That has a multiplicity of 2. I'm just going to write M2 right there so I know it has a multiplicity of 2. And I know that because it's being squared. I did not write that very nicely. This one here gives me x is equal to 3. So including the x, that is my multiplicity of 2, this is what my zeros are going to look like. Now what I know is, I have to be going, as x goes to negative infinity, my y is going to positive infinity, and as x is going to positive infinity, my y is going to negative infinity. So I know this has to be my shape. Once I have my end behavior on there, I'm going to go ahead and sketch kind of in yellow the basic idea. I know that this 0 is going to get crossed. The x-axis is going to get crossed by the graph because of the multiplicity of 1. I also know that here at 2, we touch the x-axis because there's a multiplicity of 2, so I should look like a parabola. And this one, we're going to go through again, multiplicity 1, and this one we're going to go through again and look something like this. It does not matter, let's see, it does not matter how high up we're going here, how low we're going here, how low we're going here. Those parts could be higher or lower. We are unsure of how that looks, but this is going to be the graph of the function that we were given. Make sure that you have the arrows so you're showing your end behavior. Make sure it is very, very obvious that the graph touches and turns around here in a smooth way. And make sure, again, that the arrows are very obvious as well. Have a wonderful day.